A NEET practice question, and as you can see the diagram. So in certain NEET questions you will get a diagram, and it's important that you're able to decipher the information that is coming out of the diagram. Let's read the question first, and before you read the question, don't forget to subscribe to this channel. This is the only channel which is giving explanation. We are not solving. We are explaining you what exactly is happening. So don't hesitate and immediately join. A small coin is resting on the bottom of a beaker filled with liquid. A ray of light from the coin travels up to the surface of the liquid and moves along the surface. How fast is the light traveling in the liquid? Now, if you notice the word, okay, I'm not solving, I told you I will explain you, right? So this is what is the key word here, right? So I think the concept which we have to apply immediately that comes to my mind is the concept of total internal reflection. So the concept is TIR, right? Because you are in a denser medium. The liquid is the dense medium. So this is your dense medium, and when you strike the interface of air and the liquid, you are moving along its surface, right? So when you move along the surface, you're grazing. So the second concept in total internal reflection, when the total internal reflection just starts, is the concept of the critical angle, right? So let's talk about critical angle, right? So refractive index of a medium, so which is your liquid, with respect to air is going to be 1 upon the critical angle. So what is a critical angle? If I look into the diagram, okay, so let me draw the diagram here and move my image somewhere here. I hope this is comfortable. So now if you notice, I will draw a normal here, okay, so because the angles are measured from the normal. So normal to those interface, this is the angle at which you're striking, right? So that's your angle after which it moves along, right? So when you say move along, it grazes. Your angle of refraction is 90 degree, right? We're applying Snell's law, but with the refraction being 90 degrees, right? So I hope you know Snell's law. If you don't know, go and watch my playlist on ray optics. Now we know mu is equal to, but if you look into the diagram, there is no mention of mu. Where the hell is mu? That's very important to understand. This angle will fetch us some results, right? And this angle is equal to this angle, right? These are alternate angles. Some amount of knowledge of geometry, right? So if I say this angle is also C, like this angle, then sine of C, look into the triangle. This is my perpendicular, and the hypotenuse, which is the ray, is going to be 3 square plus 4 square, right? So sine C is going to be under root of 25 is equal to 3 by 5. That's my sine of the critical angle. Question is, what is the velocity of the light traveling in the liquid? It's a very, very, very indirect kind of question, right? So the question starts with TIR, and then we reverse, engineer and say it's critical angle. We find the critical angle using geometry. We are able to find it, but the question is focusing on the speed of light. Now remember, speed of light in a medium is given by speed of light in vacuum divided by the refractive index of the medium in which it is traveling, right? All the bending actually which happens is because of refractive index, right? And the speed becomes slower in the other mediums, right? So if you are in a medium like this, which is 3 by 5, your speed will come down. Okay, so let's say what is the impact on the speed? Sorry, I think I'll just correct the formula here. The ratio has to be written correctly. So I'll just write it of the refractive index. Okay, My bad, let me just correct it. Okay, so this is mu of the medium is given by velocity of light in vacuum divided by the velocity in a medium, right? So now our sine c is known to, this is a right way to write it actually, but it's okay if you don't, right? So you know already your mu is equal to 1 upon 3 by 5. Okay, so mu will become reverse, right? So if sine c is 3 by 5, mu is 5 by 3. So 5 by 3. So I'm putting in this is equal to 3 into 10 raised to power 8 by v, and therefore v is equal to 3 into 3 into 10 raised to power 8 by 5 is equal to 9 by 5 into 10 raised to power 8 meter per second, which is what, 9 by 5. So this is 1.8, right? This is your answer. So you can see the question is not very difficult, but there are layers to the question, right? You should have been able to establish it's a critical angle. With the help of critical angle, we can find the refractive index. This is the formula for that, right? And then we know what is the concept of velocity of light in a medium in terms of refractive index. So that is the way you think logically. Practice total internal reflection, very important topic for your school examination, for NEET examination, for AP Physics, IB board, you name it, right? So I hope you like the explanation, and it'll help you retain the concept. It's just not the concept that is important, but retention, how do you start thinking about the questions when they come in front of you, is very important. So that logic has to be strengthened inside you, and that is what we stand for. So thank you very much again, and wait for my next video. I will come out with numerous videos because the exams are approaching and you need more and more help. Thanks a lot.